there's another piece to this. Some of the questions in ALEKS is going to ask you not only to graph, which we already talked about how to graph, where you graph and then you shade, but this one goes a step further and asks you to find 3 ordered pairs that would be solutions. Now, what is a solution? Remember, that's the first question that you're going to get on the unit test. You're going to be given ordered pairs, and we ask you to plug it into the original problem to see if you get a true or false statement. If you get a true statement, that ordered pair is a solution. Here, they're not going to give us ordered pairs. You're going to have to tell me what those ordered pairs are. If we shade the graph, then any ordered pair found in the true region would be a solution. So you still want to graph this first and do your shading, and then you just take it one step extra by looking at the shaded region and just try to find ordered pairs in there. Anything that would follow into that side would be a solution. So any ordered pair that's found in the true region would be technically a solution to the inequality. So again, pretend that you have an equal sign, and then we're going to solve the equation for the specified variable of y. Notice, if I pretend that this is an equal sign, you can see y is not by itself. So it wasn't like the other guy that we have. This one you actually will have to tweak. We will definitely have to do step 2 here. You know how to solve for the specified variable y. We talked about this when we were trying to find slope-intercept form. Underline the y, see if there's anything that's added or subtracted to the underline. See how this 7x is added? So do the inverse of 7x. So this is positive, the inverse would be a negative 7x. Whatever you do to the left, you have to do to the right. They cancel out because they're inverses, so I'm left with positive. See how I bring down the plus sign? 5y. Remember, this is a constant, coefficient variable, cannot combine. So we put the variable term first, and I always say put the constant term last. Since this is a positive 10, notice how I'm going to put a plus sign to separate it from the variable term, and then put the 10. Now, my last step is to get rid of the coefficient of y. Notice I have a 5, so I want to get rid of the 5 by dividing, not only by the number, but its sign. So I'm going to divide every item by a positive 5. Positive 5. Positive 5. So these cancel out, giving us y equals negative 7 divided by 5. Remember, you're not allowed to put this as a decimal point. Okay, so I don't want you to say, well, isn't this going to be negative 1.4? No. Leave it as a reduced fraction. So you know negative divided by positive is negative, but 7 divided by 5 doesn't go in there evenly, and 7 and 5 are prime numbers, so leave it as 7 on top, 5 at the bottom, and then you can take the x and just put it to the side. Remember, when the x is found on top, you can slide it away from the fraction bar. And then 10 divided by 5, luckily that divides out evenly, that's 2. So we did step 2. Step 2 was solve the equation for the specified variable of y. Notice y is by itself now. Because it's by itself, we can finally tell me what the y-intercept is and what the slope is. So notice, y by itself this is your y-intercept. Remember, y-intercept has to be 0, comma, whatever the constant is, 2. And this is your slope. Okay. Perfect. Notice, if you did not get y by itself, Yeah, that's definitely not our y-intercept because we found that it was 2, not 10. And 7, yeah, my slope is not 7, it's negative 7/5. That's the reason why you have to get y by itself. Okay, you just can't randomly grab the constant and the coefficient of x. You have to get y by itself. Once y is by itself, then you can grab those two pieces. If not, you're going to grab something that is not the y-intercept and something that's not the slope. Next, plot the y-intercept on the graph. So we know to plot, just find 0, 2, y-intercept on the y-axis. So find 0, boom. Rest your finger, remember don't make a mark yet. You have to go up or down. Since it's a positive 2, go up 2 units. Now you can make a mark. Remember, y-intercept is 2. I'm going to be on the y-axis at 2. Alright. How do we get our next point? That's step 5. Use the slope to go to the next point from the y-intercept. So make sure the slope is written as a fraction, and then use rise over run to figure out how you move to get to the next point. Notice we said our slope is negative 7/5. It's already a fraction, 7/5. Now it's your decision. When it's a negative in front, either put it on top or put it on the bottom. I'll put it on top. I don't know why, I like to put it on top. Okay, so this, since it's negative on top, remember that's either up or down. Negative means down. And then the bottom, since that's positive, remember left or right, when it's positive, you go to the right. So let's go down 7 units from where? Always the y-intercept. 1, 2, 3, 4, 5, 6, 7. Now, rest your finger because we have to go to the right 5 units. 1, 2, 3, 4, 5. Now I can make my mark. Okay. So I went down from here and I went to the right 5 units. Okay, so you have to go up or down and then left or right. Then you can make your 1 mark. So now that I got my next point, I'm going to have to connect those points. So let's look at the original problem, because remember, am I doing a solid line or dotted line? Anytime you see this greater than, equal to, see how it's like underlined, if you think of it in your mind? Like that's a solid line, then you know you're going to connect as a solid line. So from here to here, as best you can, connect in one straight line. Luckily, Alex is going to do that for you. So that pink line, that pink line is your border. So we got to determine, do we shade above that hot pink line or below the pink line? Well, now that I'm in shading, it says grab a test point. You get to decide what test point you want to use. I like 0, 0 if it's available, because you saw how easy plugging in zeros are. 0 times anything, 0 added to anything is always the other guy. So it's so easy to use zeros. So I look to see if that test point is available. So where's 0, 0? Right there. Not on the hot pink line, so that's good. We can grab that. As long as it's not on the boundary line, you're good. So what do I do? Now that I know I'm going to use 0, 0, and that's the test. A lot of people ask me, where do you get 0, 0 from? It was random. You can plug in any point, as long as it's not on the pink line. I always use 0, 0 if available. If your lucky number again is 3, 3, then that's fine, because 3, 3 is not on the boundary. Do not pick 0, 2, because it's right on the pink boundary line. Okay? Stay away. Do not pick 5, negative 5, because it's right on the pink boundary line. Try to pick something around it. Alright? Now that I'm going to choose 0, 0, you plug that in to the original inequality. So every time you see x, put in a set of parentheses. Every time we see y, put in a set of parentheses. Greater, equal to 10. Because I'm going to plug in my x is 0, my y is 0. So let's simplify so we can determine true or false. 7 times 0, yeah, that's 0. 5 times 0, remember how I'm distributing first? Yeah, that's 0. 0 plus 0, yeah, that's 0. Now let's determine true or false. Alligator thinks 0 is the bigger meal. Let's see if I agree with it. Would I rather have $0? Would I rather have $10? Yeah, I'd rather have $10 in my pocket. So I'd rather eat the 10. Alligator, for some reason, wants to eat the 0. So we're in a disagreement. Anytime you disagree, it's a false statement. Okay? So where am I going to put a letter F for false? Right on the test point. My test point was 0, 0, so notice I put an F right where the test point is. So we're going to shade. Remember, you're only shading the true side. So I'm not allowed to shade below here because that'd be shading the false side. So if I know this is false, then all this by default must be true. Okay. Now you're not done yet. We just did the graphing part. We need to get those 3 solutions. So let's erase, because I know this board's a little crazy. So you need to tell me 3 ordered pairs that would make this a true statement when plugged in. Well, instead of me trying to randomly grab something, let's grab points. Here. Remember, anything in this side would be true. So, this, not on the boundary line, in the red colored in zone, that's a good one to grab. What's the ordered pair for that mark? X is 5, Y is 0. Again, grab any point in this red area. You can decide. Let me grab this point. What's that? X is 3, Y is 3. Again, you can grab any point. Alex will accept any point. If you're that person who likes to stay on the axis, that's fine. If you're like the ones who like to float around, that's fine. So maybe you want to float and you want this point. That's 4, 1. X is 4, Y is 1. You can grab anything. You can grab a point here, point up here. Doesn't matter. As long as it's in this red area. If you plug all these in, you get a true statement. Plug in 7 times 5 is 35. If I plug in a 0 here, 0. Is 35 greater than or equal to 10? Yeah, 35 is greater than 10. True statement. If we did 3, 3, this would be 21. This would be 15. 21 plus 15 is 36. Yep, that is greater than 10. True statement. Again, that is a solution. Remember, anything plugged in that gives you a true statement is a solution. 4, 1. 7 times 4 is 28. 5 times 1 is 5. 28 plus 5 is 33. 33 is greater than 10. Each one of these, when plugged in, gives you a true statement. So you can give me any ordered pair as long as it gives me a true statement when plugged into the original inequality problem.